Let's consider some practical aspects of spontaneity. Say we have water and we want to look at water evaporating from the liquid to the gas phase. So you know that if you go on vacation, if you have a glass of water and you leave it out on the counter and you go on vacation and come back 2 weeks later, that water will have evaporated. So that looks like a spontaneous process. It just happened by itself. So let's look at the delta G for the evaporation of water. So if we look at delta G for this reaction, which is vaporization, so we go to a table and we would look up the Gibbs free energy formation for water in the gas phase and subtract the Gibbs free energy formation of water in the liquid phase, product minus reactant. So let's do that. So water in the gas phase minus 228.6 kilojoules per mole minus water in the liquid phase minus 237.1 kilojoules per mole. So this is equal to 8.5 kilojoules per mole. Well, first of all, you'll notice that it's positive. So this is not spontaneous. So delta G has to be negative for a spontaneous process to occur. But it happens, so what's going on here? Well, let's look at what we have done in our calculation. We went to a table and we got delta G formation, and this is standard state, 1 atmosphere pressure. So when we got water in the gas phase with this value right here, this is water in the gas phase and its value. This is for water, gas at 1 atmosphere pressure. So water vapor at 1 atmosphere pressure has this value for delta G formation. So when we are in our room and we put a glass out on the counter and leave it, the water pressure in our house is not 1 atmosphere. The total atmospheric pressure is about 1 atmosphere, but the actual water vapor pressure is very, very, very small, much less than 1 atmosphere. So even in Human, Mississippi, the partial pressure of water in the air is very, very small. So one thing we're doing is we're using values from a table that don't pertain to the actual system. So if we have water in a closed container and the pressure of the water is equal to 1 atmosphere, we have some water liquid here, then it would spontaneously condense into the liquid, because the reverse of this reaction is just the negative of this one, so it would be negative 8.5 kilojoules per mole, so that would be spontaneous going from vapor to liquid. So this would liquefy, but we don't have 1 atmosphere water pressure, so this calculation actually doesn't pertain to that example. What we'd have to do is correct delta G formation for water vapor down to the actual partial pressure in the air. Then if we do that, then we'll find that delta G for the reaction is actually spontaneous. So you have to be careful when getting values out of the table, knowing what they pertain to and what conditions were they measured. And so this is delta G formation at 1 atmosphere pressure. So if it's a gas, 1 atmosphere pressure of that gas. And if it's a liquid, 1 atmosphere pressure over the liquid. If it's solid, 1 atmosphere pressure over the solid.